Okay, I'm pouring myself another pot of coffee, or I made another pot of coffee here. So I'm back on the Carver. The customer's calling. How's it going? Well, the transistor just came in and I've gone ahead and replaced that MPSU60 with the MPSW92. It's a PNP. It's a good thing I checked because I was almost going to put the 42 in, but you have to put the 92 in. And it's right there. The working channel, and here's what we replaced. I also have to go in and change that 56 ohm because that's open, and this transistor is definitely shorted. So, and this is the transistor, the MPSW92. Double check our basing, and I'm going to just replace the shorted output transistors. I'm not going to do all of them, but I just want to see if this thing turns on. The capacitors are installed. I don't know if you saw that. That was a feed in itself. I think that's the last of the shorted driver transistors. I hope the diac and triac is okay. It seems to be. We'll put a load across the speakers here and turn this thing on. See what happens. There are ways to turn this on by jumping the diacs and removing some connections, but I'm not going to get into that. I'm just going to fire it up and see what happens. Okay, that's it. Oh, and I should get the bottle of aspirin to put next to this cup of coffee. But maybe I'll save that for the B&K 530 transistor tester, because I've ordered the JK flip-flops and some op amps for that, and some 14-pin IC sockets. That's going to be a nightmare, but we shall persevere in getting that thing running, hopefully. Okay, I'm a little short-handed of a 56 ohm. I've taken that out. I've put a couple hundreds in parallel, which yields us about 50. That's fine. And I've mechanically joined the pieces together before adding solder. Okay, now that's done. That's the original 56. And we got 200s in parallel. See the other one under there. Okay. All buttoned together. Okay. We're going to replace the 4 shorted transistors. They're the ones with the red dots, and fire it up. We know this channel's okay. I wish there was a way, it probably is, to undo the power to this channel, but I'm not messing with that. Let's give it a try. Okay, I believe that's all of them. These are all numbered in the same fashion, NEC. This one here these here are a little shaky. Although they have date code. Looks like a number was scraped off and that's stamped on there. I don't know, because they don't follow the same pattern lettering wise. But okay, that'll do it for that. And I'm using this, I didn't notice when I bought it, but got it one of the Hamfest, non-silicon heat transfer compound. Wiped away the old. Don't know, never used non-silicon. I think it's discontinued or something. I don't know what someone will have to chime in on the difference there. But I've always used silicon based, but anyhow. Okay, I'm still getting a bad reading on these two here. One is the new one. So I'm going to take out that first one. Okay, I've gone ahead. There was one last man standing here, and I've replaced him too. So that makes a complete set of these. The complementaries, I've not. I've just changed this one. We'll see how they read. I think this one does read differently. Okay, a couple of these still check good. The one I had marked with green there, that tests good, and one other one tests good. However, there's still a problem with these two reading short, but they're not short, obviously. I'm going to have to look at one of these driver transistors here. Go back and look at the schematic again. Okay, more guessing games. There's nothing in the manual that tells you which transistor is which, or maybe this does. Okay, I take that back. Okay, here we are along. Alright, so let's see which one's giving us the problem. The one that's down by the input connector. Q1 and Q2. If this sits like this. 14's at the top, hopefully. That looks about right. Okay. Q1 and Q2 here have a problem on this channel. I'm suspecting there's a driver here somewhere. There's Q15. We're going to look around here. There's something not right. Q1 and Q2 are right here. These read different than all the rest, but they're coupled the same. Q22 and 21. Q22 and 21. I don't know why just these two would read bad. Q1 and Q2. They just have low ohms compared to the others. That must be Q22 below D23, but I can't find Q21 for the life of me. Q21 is supposed to be right near Q22, or 4.7 ohm between them. Yeah, I'm missing it. I'll keep studying here, but I don't see any Q21. Okay, I think I found the problem. Q22 right there under that diode is shorted. I'm guessing I'll take it out. That's this one right here. ECB, I'm guessing. I don't know. But if I go to collector to the base, I haven't looked it up yet, but does not pass the diode check. And it's dead short. And if I compare with our other channel here, you can see it's charging a capacitor. And if I do diode check, yeah, it's fine. Where's this one over here? Yeah, dead short. Okay, I'll stop it for now. We're going to take this one out of here now. Glad we didn't plug it in. Glad we did some checks. So if we look at this, it's the MJE 2955. It's shorted between the collector and the emitter. Pins 2 and 3. And the high current transistor. Oh, I just want to throw something in here, but I'll research more parts. Okay, so we ordered the MJE 2955. That must be the complement to the 3055. And again, it's that one right there. That should do it for shorted transistors. Everything else reads okay. This channel is okay. The one on the right. This channel's okay. It's this channel here. Okay, so that'll do it for now. Again, parts hold on the Carver. On the Carver, and the transistors came in quite quickly, actually, just a day or so. The post office is really cranking. Pain in the neck to install because they must assemble these boards first and then solder them in here, because it's like, I got to it. It's impossible to get those 3 legs in there, but I did so. I'm not trimming them. All the sides read the same. I don't have any shorts or anything. I've added some 15 ohm resistor loads to the outputs as a safe measure. I'm going to power this thing up, but what I don't like is this one new transistor here reads different than the others. That one that's got the stenciling in the opposite direction. I don't trust that transistor. It's not shorted, but it does not read the same as these others, meg ohm wise. These have about 2 meg ohm, I think, between the emitter and base, and this one has like 10 meg. I don't think it's the same transistor. It just looks like something that they stamped a number on. But anyway, we're going to power this up and just see what it does. I did replace that whole bank of these. I'm holding off on those. These test okay, and the other channel is fine. So here's the big killer cure here. This is the new capacitors over here. The wiring is back over here the way it should be. One transistor, another transistor here with the 50 ohm instead of 56 ohm. Like I say, this channel seems fine. I'm just going to power it up and watch for the smoke here. I'll set this down. Does this have a power switch? Yes, main on. Sequencer, I don't know what that is. Power sequencer on. I don't know what that does. Oh, for other amps, I'm sure. Clipping, normal. Volume down. Put them up maybe one click. Watch the meters there. And put some AC on. Okay, and action. Okay, the UPS went a little cuckoo, but no smoke. Two green LEDs over here. Fan is running. Let's power down and check for heat. See, everything's cool, but that one transistor is getting hot. That one suspect one. And it started cutting off, and that one transistor right there. You'll see it was failing. The resistors are cold. I could smell something getting hot. Taking that transistor out. Okay, because I have enough transistors for both channels, I went ahead and I've just changed all these out to the same. None of these are shorted, but there's the one new one and the 4 previous. But because they're breaking down under high voltage or something, we'll replace them all. Hopefully there's no damage. It didn't go into protection, but the power supply was surging, and the lights started taking on some kind of signal. I'm going to have to try it again real quick. Okay, just see. Ooh, you get a little shock from this thing. These are high voltage, alright. After it being on, it started going a little berserky. All the set of transistors in. I don't have any heatsink compound on them yet, but I'm just going to watch it a minute. Alright, that's enough test. That one transistor was getting hot. As I was saying, another member suggested checking the gain of each of these new ones, which I cannot do. I'm not driving it. But these transistors, this was in a shorted channel, so although they test good, yeah, they may be breaking down under higher voltage. Oh, cool. Whoa, see, hot. One's getting hot, this one right here. This one right here. Warm. Cool, 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 cool. Warm. No good. Oh, he's warm too. Cool, 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 cool. These transistors do a different function though. I think there's 4 and 4. Let me see what these two numbers are here. These may be doing another job. 1, 2, 3, 4. These two in the middle here. We'll get their numbers. But see, these aren't getting warm. Let's try this again for a minute. That's not... cool. These are getting warm. I'm getting a little tickle off them too. No, there's something wrong. These are getting warm. They're all getting warm. No, just these two. Just those two. Okay, although it's upside down, it's Q1, Q2, Q3, 4, 5, and 6. These two right here in between Q16. These are the two that are getting hot. Q5 and here's Q6. Q5. Here's Q6. Get these diodes on the base. These 3 watt and 5 watt resistors. Is this where they both come together here? 5 and 6. This is where the two. And we got Q23 here in the middle of it all. This resistor. I'll look around here, but look at the Q23. But I really don't know what's. The other channel is fine. It's just this channel. Okay, our suspect transistor I was mentioning, Q23, which is right here. If you can see that, there's, for all intents and purposes, it's Q5, but it's the 6th transistor from the right, the way this is orientated. And there's C5, there's a diode, and this transistor Q23 right here I was talking about next to that resistor. That's right here. You can see the singe mark next to the resistor. There's also goop under the transistor on the board there. I hope this transistor is bad. It doesn't look very good from this angle. Okay, the good thing about stereo is you get another channel to experiment with. I can't do diode check on the transistor in circuit. There's just so low resistance across this transistor. I could show you on the schematic. I think it's a 40 something. You see that right there? They're very low ohm resistors. And that one looks charred. And that transistor looks like it just doesn't look good. We're going to take it, and it reads lower. This has about 100 ohms and then 43 ohms, and this one's like 25 and like open. We're going to check right here. This is our next trouble spot. Okay, like I was saying, one's a 60 something ohm, one's a 47, I believe, and one's a 62, some oddball. In any event, these read normal in this channel. This one is open. The 6 to 50, I don't know what ohm that is, but anyway, this one is open. This one reads 25 ohms in circuit, so that transistor might be shorted, and you can't read it in circuit. I'm going to take it out and check it. Well, I guess you go to unsolder the transistor, and one of the legs is just comes off, stays on the board. If you can see, where are we? Right in there. Yeah, I'd say that transistor is bad. It's cracked. Split. Yeah, that's cracked. That thing's toast. That thing, it didn't smoke up on us. I think this, again, it's open. Let's see if we can throw something in here. Again, that's our transistor there. That's a NPN. These handwritten drawings, man. 80, it looks like 87, but it's actually 8097. Because if you go over here and look at 18, 8097. This resistor, these are the two I'm talking about. This 62 ohm is open. This one's fine, 4362. We're going to throw something in there. And we're going to throw something in here, NPN. I don't care what it is. I'm getting tired of this. Transistor we were working on the B&K 530 with as our test transistor, and that's a BC337. That's also an NPN. And this MPS in 8097 is a general purpose NPN. I think I'm going to be able to use this. but I know it has a different configuration. You're gonna love the internet though, telling us here CBE. I'll look up the data sheet in a moment, but then you have this site telling you hand-drawn EBC. It's but this one says CBE. So let's see what this transistor's pinout really is. CBE. This is a good 800 milliamp current. The voltage is about the same. 40, 55, 800. Gain I'm not worried about. Not worried about it. There we go. CBE. And what's the MPS? The MPS is EBC. So we're just going to switch those legs around. The other one's CBE. We're just going to put it in backwards. CBE. So it's EBC. EBC. So like flip it over. And there's our EBC. Put it in backwards. There's our transistor right here. Our European transistor in backwards. Silly Europeans. You know I'm just teasing when I say that. Probably say the same thing. Everybody's got to switch it up. The Japanese do their ECB. We do EBC. And this one's CBE. So we just flipped it around. Okay. Change that transistor and resistor now. Get as close as we can to 62 ohms and fire it up. Okay, I want to thank our Samtron monitor again. I thought it was a Gold Star, or that may be the one over there. But anyway, first I was going to 47, but I managed to find a 33, and I have a new 33, so it looks like it's going to be 66 for this one. 33 and 33 to give us 66 ohms. Oh, I didn't measure it. I'm sure that's fine. The transistor in backwards. I just say that because the polarity is different. Let's fire it up and see what it does this time. I want everyone to be aware of. I was soldering and I dropped some pieces of solder off, and see this piece here? Yeah, I don't know what that is, but we call it lead poisoning. You know, in the chassis days, get that out of there. You don't want any fragments. You drop something, solder in there, you get it out because it finds its way in between a couple legs of the ICs or something, then you're really in trouble. We called it lead poisoning. Somebody would be soldering a chassis and the solder drips down, shorts a few traces, or on a chassis it bridges a couple connections, and then you're really in trouble. Okay, here we go again. Here myself, but we have power. Turn our power off, turn our mains on. This time we're going to power up. New transistor and new resistor. Okay, we ran out of memory there a minute ago, so I've been pretty liberal with the heatsink compound. I got some on the transistors. I'm going to stick these back in here, fire this thing up, and I have a 1/4-inch jack to feed a signal in each channel. I just want to see something on the meters. Then I'll hook speakers up and play sound. So open this up. I have all the transistors in, tightened down with heatsink on. Basically, we changed the whole channel. Leave these alone. We have good transistors, but we'll leave them. We'll plug this thing in one last time. And apply power here. Turn that off. Turn this on. Turn this on. Doesn't do that funny red. Okay, I'm going to turn this on again, and I have an input signal. I'm going to throw an input in and see what we get on the meter, if we get any life. So on again. And go in the back. We'll try one of these channels, see if we get any. We'll get anything on them. Oh, but this. Bring up the level a little bit. I'll bring the level up. I don't know which input I'm selecting here. If I'm the XLR or the... No, I don't know. There's a switch here that's in. Maybe this isn't enough. There's not enough gain just by touching it with your fingers. Okay, we'll run a signal in here. I have the cassette deck running, and I'm feeding this thing an input. I have the gain way up. I don't know what it takes to drive this thing. It tells you 1.5 millivolts or something. 1.5 volts sensitivity. So maybe I'm not driving this thing. Maybe it is playing, but just not enough for the meters here. So it's got a little TL072 chip there. I have sound here. I've tested that. This jack configuration, and I don't have any XLRs. But I don't see a thing on the meter. Okay, so I brought up the TL072 on the computer. I'm hitting input. Oh, pin 2. Pin 2? It causes the fan to speed up, and there must be signal there. So that's good. Let's hook a speaker up. Let me lower this. I'll lower this down. Go back to input pin 2. I have the other lead on ground. Oh, I don't know what is on pin this. Pin 2 again. Hey, it's got, I'm sure it's playing. It's got a little blip on the display. Let's put up the gain a little. There we go. What are we, in between songs here or something? Come on. Must have been. Okay. Let's try it with a speaker. I'm going to turn this on with our test speaker attached there on the left channel. Left channel. And I can't seem to get any inputs in this in the back, so I'm just going to go back to that chip. I have the lead grounded, the tape is playing, and I'm going to just hit input pin 2 here again. Oh, I didn't like that. It stopped immediately. Pin 2. Pin 3. Okay. Whoa! Don't short that chip out. Jesus Christmas. Oh, sure. We probably just blew that chip. You are kidding me. What's pin 4? Ground, of course. Now we have nothing. Oh, good news, bad news. We have levels on the meter still out front, but this speaker is wide open. It fried that thing. You can smell it. And it's wide open. It's a good thing we used a test speaker. That's why it's a test speaker. Well, anyway, take my word, that's open. Let's put another speaker on. Once again with our speaker attached. Power over here. I'm going to call this a wrap pretty soon here. Power on. I still don't hear anything out of this speaker. Carefully inject a signal. Well, figures the end of the song, of course. But there's nothing on the meter with that much. Oh. I'm going to be careful here. Let's go to pin 2 again. Hey, hobos need a lovin' too, you know. Wow, and that's just... This thing is loud. That's the left channel. Let's turn that down a little. Better check this chip out. We sparked it.
the hillside and let that blue sky.
That's pin 2, input. Let's try the other input, which is pin 6. That's pin 2, which is the minus. What does pin 3 do? It's lower. So let's go over to pin 5 and 6. This is 5. Of course, we're in the other channel now. Alright. Go to the other channel. The other channel. We'll work on the inputs later. I'm going to turn this thing on. I've moved the speaker over to the right channel. And I'm going to try pin 5 and 6. Let me see what my level is here. That's way too high. You can't even hear hiss or anything out of this speaker. Let's go pin 5 and 6 here. It's pin 5. 6 is... This thing's loud, man. I'm going to stop here on the Carver. I'm going to call this a... It's not even bumping the meters. I don't know why I get no input on these silly inputs here. I'm going to have to look into that. Oh, this one has it. Okay, so let's reverse the speaker and let's try this jack again. Put signal test, take 2. I have a speaker on each channel. Power this thing on. Set the levels about there. On. The damn lights blink when you turn this thing on. Hit play on the tape. I'm going to try at the inputs here. Okay. We are good. We are good. I could even take the other channel. He sang western swing and songs of grief. Alright, get in there. That same tune gave old Hank the break he needed. On a record called... Let me get a bump on the meter here. A young girl, just one. Stop and listen. That's gonna do it for the Carver. That's it. I'm stopping here. Thanks for watching. It wasn't gone. I changed the tape to Bob Marley and the Wailers because the other one gets so many copyright hits. Just do one more. We're gonna leave now. Sounds like crap. Let's just do the recording. So here we go. Just like crappy tape. Let the music rock me. 'Cause I've got to love, darling. Love, sweet love, darling. Quiet as the night. Okay, so the owner's been contacted. Basically, we replaced these caps with a kit they made. They were labeled incorrectly. They may not be bad. We may have been testing them backwards because this polarity is incorrect. A few output transistors and 3 small signal transistors and a few resistors. So that's what it took to get the Carver back online. And he should enjoy this for, let's say, at least many years to come.